We're going to have a look at the fast version of the chain rule, but in order to do that, I just need to elaborate something first. And so I just want to stop at this point of using the chain rule. I want to spot a pattern here so we can do this process a little bit quicker. Firstly, it's broken up into three parts, finding the derivative of y with respect to x by using this u substitution. Our first part here came from the power. Okay, they came from this power right up here. Okay, and we've got part two, which is our inside function to the power minus the 1 of what it was. And then we've got a third section over here, which is just the derivative of the inside function. Okay, so it's chunked up into three sections. Here we've got section number 1, section number 2, section number 3. Let's apply using this chain rule a little bit faster. Let's have the same function. If I'm going to be using the fast chain rule, this is how I can structure it, and I'm just spotting a pattern here. In order to find the derivative, I can see that the first element came from the power. So that is that 5 in the power. Look at the power, it's 5, I bring that down. And then I write out u, which is the inside function. Again, u does not change, to the power of whatever it was minus 1. In this case, 5 minus 1 gives us 4, and then we need to multiply that by the derivative of the inside function, which is just going to be 4x. We can clean that up to be 20x by collecting 5 and 4x there, outside of 2x squared minus 1 to the power of 4, and that is our derivative using the fast chain rule. Okay, and that is exactly what we would have gotten if we just continued simplifying down here. We would have said we've got 5 times by u to the power of 4. U is our inside function. Okay, and so we have a nicely factorized derivative, which is very nice. Let's apply it. Let's apply it to another example. Because here we've got to differentiate this function here. Now I'm going to need to use the chain rule because I have got a function within a function. And if I express it like this, maybe it's a little more obvious. It's to the half power, that's what a square root implies. So here I'm going to find the derivative by using the chain rule. And I'm just going to apply my fast chain rule here. That's spotting the three sections of what create the derivative. So I've got dy dx being equal to, the first part was the power. In this case, the power is a half. So that half comes down. The second element of it is u, which is our inside function, to the power of whatever it was minus 1. So the inside function stays the exact same there, to the power of minus 1 of what it was. So it would have a half minus 1 gives us negative a half. And then I need to multiply that by the derivative of the inside function. That is my third element. This is element number 1, element number 2, and this last guy here is going to be element number 3, which is the derivative of the inside function, which is the derivative of that there, which is going to be 2x minus 3. Just need to clean this up a little bit. Okay, where I might express that negative power on the denominator, so I'm going to have 1 over 2 x squared minus 3x plus 1 to the power of a half. So my denominator multiplied by 2x minus 3. And I might just throw that 2x minus 3 on top of the numerator and express my answer with a surd. So I would write it as 2x minus 3 over 2 the square root of x squared minus 3x plus 1. Okay, that is our derivative there. If you want to double check it using a differentiation calculator, go for it. Third example here is a little bit harder. It is using the chain rule, however, we're going to have to use the product rule. And so this question, I would say, is actually quite complex. And we saw from the product rule is that the complexities come from the simplifying process. In this sort of question, I'm going to show you a new trick with simplifying derivatives. So here, I'm going to have to find, and that's because here I've got a u function, and here I've got a v function. And what we'll notice with the v function, in order to find v prime, I'm going to have to use the chain rule. And it would be nice if I didn't spend all day doing it, because I've then got to do the product rule. So this is where the fast chain rule is going to come in handy. So I know y prime is going to be u prime v plus v prime u. That is my product rule. And I'm just going to write out what u is. I'm going to say it's x to the power of a half, because that's what the square root of x is. I'm going to say v is this inside function to the power of 7. U prime is a half x to the power of negative a half, where v prime, that's just applying the power rule there, and this guy over here, that is to the power of 7. Okay, we know that 7 comes down, inside function stays the same, to the power of 6, multiplied by the inside function, which is 4. Clean that up, bring that 4 and 7 together, and we get 28 outside of 4x plus 1 to the power of 6. And so here I'm just going to plug everything back into my product rule and try and simplify my derivative. Okay, and so I know there's a lot of parentheses here, but this is just to illustrate that we've got u prime here and there, multiplied by v, which is this guy there. Okay, now I'm just going to simplify this expression a little bit just by writing things with positive indices and in surd form. So I'm just going to clean this up here. This first guy is going to be 1 on 2 root x multiplied by 4x plus 1 to the power of 7. That's that first part there. The second guy here, I'm just going to rearrange. I'm going to bring this square root here to the front, so square root of x outside of 28 multiplied by 4x plus 1 to the power of 6. And we can't really do any expanding here with this 28 times by 4x plus 28 times by 6, because that bracket is raised to the power of 6, and you just can't do that. You'd have to do some binomial expanding. We're not going to do that. And so now here comes the new, I guess, trick component to simplifying this expression here. And what we want to do is we want to, and I'm going to write it down, we want to spot a common factor. So we've got u prime v on one side and v prime u on the other side. There should be some common factors that we can pull out to help simplify the expression. This one, again, it is a little bit of a trickier one. It is not so obvious. However, what we're going to have to do, and I'll try and indicate this in a yellow here, is for this expression here, I'm going to multiply it by 2 on I'm going to multiply it by 2 square root of x divided by 2 square root of x. That's just multiplying it by 1. The reason I want to do that is because I want both sides of these, I guess, things here, which is the u prime v and the v prime u, to have a common factor in which I can pull out. So I'm going to force the second guy, v prime u, to have a common factor with 1 on 2x on the denominator. Okay, and maybe to make it a little bit clearer, I'm going to rewrite this section here on the numerator. So that is just going to be 4x plus 1 to the power of 7 on the numerator. And just bring this over a little bit here. Okay, and if I just simplify this side here just a smidge more, again, these are a little bit tough. What we will see when we simplify it down is we get a nice common factor that we can pull out. And so if we do here, we've got the square root of x times by the square root of x, which is going to be x, and that 2 hanging over there, so I just get 2x outside of 28, 4x plus 1 to the power of 6, all over 2 square root of x. And so here, my common factor that I can pull out here, which is common across the two terms, is going to be, well, I spot that both terms have got a denominator of 2 root x, and I spot that they both have multiple factors of 4x plus 1 to the power of something. So I can pull out that as a common factor, which the common factor would be 4x plus 1 to the power of 6 over 2 square root of x. That's our common factor that we can pull out between the two. And so then what we do is we find out, well, what do I need to multiply that common factor by to get this original term here for the first one, which I would say that, well, I'm only going to have to multiply it by 4x plus 1 to get it to 4x plus 1 to the power of 7, because I've already got to the power of 6 pulled out, and then plus, well, what I'm going to have to multiply that common factor by to get this expression here. And so I've pulled out the whole 4x plus 1 to the power of 6, so that's not really going to be there anymore. I'm going to be left with 2x times by 28, and that denominator will be left over there. And so my common factor, which I've pulled out, is this guy right here. And then now I can simplify this expression a little bit more, just to dust it off. And so this would be my nice final answer for the derivative right there. Process, it's long, but that's our trick.